So what happens here is that when photon will collide with the electron, photon will transfer some of its energy and momentum to electron. Okay. Hello everyone, a very good morning. Guys, today we are going to study about a very important experiment that demonstrated the particle nature of light, that is Compton Effect. Now see guys, there are basically three experiments that are very important in establishing the particle nature of light. The first being the photoelectric effect, the Einstein equation of photoelectric effect. Second is black body radiation experiment, and the third is Compton effect. So today we are going to talk about Compton effect, and we are going to understand that what this Compton effect is, what is Compton shift, okay? And rest of the experiments we will do in some other videos. So let's get started. So guys, as I told you that Compton effect established the particle nature of the light. So see, what happens is that whenever a high energy photon, now we all know that light is made up of photons, yeah, if you consider the particle nature. And what is photon? These are packets of energy, okay? So when a high energy photon with a specific wavelength and frequency interacts with charged particle. So see, when high energy photon is going to interact with the charged particle, here I am taking the charged particle as electron. Electron has got negative charge, okay? So this is light as a wave. Light is incident on some atom. That means photons are going to collide with the electron, and electron is our charged particle. So what happens here is that when photon will collide with the electron, photon will transfer some of its energy and momentum to electron, okay? Some of the energy and momentum of photon is transferred to electron, okay? Now see guys, due to this, what will happen to photon? See, frequency of the photon will decrease, wavelength of the photon will increase, and also the direction in which photon was moving, it is going to change. See, here as we observe that photon was moving horizontally. When it strikes the electron, it has transferred some of its energy and momentum to electron. Thereby, the frequency of photon has increased, frequency of photon has decreased, wavelength of photon has increased, and direction has changed. Okay, see guys, it was moving horizontally, now it is moving like this. So in comparison to horizontal, now it is making some angle. That's indicating the shift. Yes or no? Okay. Now see, this increase in wavelength of photon is known as Compton shift. This increase in wavelength of photon is known as Compton shift. Fine. First, and now guys, that how much the wavelength has increased. I told you that increase in the wavelength of photon is Compton shift. So how much wavelength has increased? For this, we say that the collision between the photon and electron is elastic collision, okay? And if collision is elastic collision, then easily by conservation principle, we can find out the change in the wavelength, and change in wavelength comes out to be h upon m naught c, where c is the speed of light, h is constant, you know, and into 1 minus cos theta, where guys this theta is known as scattering angle. See, I have made this theta here. This theta, the angle by which the direction of photon has changed, this is known as scattering angle, okay? So 1 minus cos theta. Now it is evident from the formula that greater the value of theta, more is the value of theta, more is the value of scattering angle, more will be the Compton shift, right? Greater the value of theta, greater will be the change in lambda. Lesser the value of theta, lesser will be the change in lambda. Understood? Okay. for theta equals to 90 degrees. See, if you'll put 90 degree, cos 90 is 0, delta lambda comes out to be change in wavelength or Compton shifts comes out to be h upon m naught c. And when will the shift be maximum? So shift will be maximum when this scattering angle is 180 degree. When theta is 180 degree, then delta lambda or change or Compton shift comes out to be h upon m naught c. Compton shift or change in wavelength, whatever you want to call it. Okay. So guys, this experiment, this effect, I have just introduced this effect to you. I've just explained the basic concept that what happens, what's the concept of Compton effect to you, and we will do it in detail with all the derivations in the class itself. Okay. And this experiment was very important and pivotal in determining the particle nature of light, and it laid the foundation of quantum mechanics as well. Okay. So I hope you enjoyed the video and understood the concept. I will see you in another video, maybe regarding black body radiation. Thank you. Take care. Bye.